Hey guys, so in our unit about energy here, this is going to be the last part of the unit. So far, we've talked about work and we've talked about energy, and the third big piece of this puzzle we're going to talk about is something called power. Okay, kind of three pieces of a puzzle here, right? Work was the change in energy, and as we're about to talk about, power is how fast work gets done. So energy, work, and power, all kind of three pieces of the same puzzle. Our target, we're going to want to be able to calculate how much power is involved, right? So let's get to that. Okay, so like we just mentioned, power is how fast work gets done, right? It's the rate at which work is done. And since work is the change in energy, power is how fast the energy changes. So power is how fast energy changes, how fast work gets done. It's actually very, very simple to calculate power. Power is just the work divided by time, right? So if you know the work, you know the time, divide them, you got the power. Power, we use the symbol P for power, capital P, and we measure it in a unit that you're probably already familiar with. We haven't talked about it in class, but you've probably heard it in your life quite a bit. We measure power in watts, W-A-T-T, watts, and watts is abbreviated with a capital W. So we can calculate the power by taking the work divided by the time. Fairly simple. There will be problems where they'll tell you the work, they'll tell you the time, and all you have to do is divide. Boom, right? Easy. There will be other problems where they don't tell you the work. If you recall, we've learned several different ways so far to calculate work. So some of these problems you're going to have to first take one step, calculate the work, and then after that, you'll go on and find the power. So kind of like two small problems, right? Two small, easy problems. Sometimes they'll just tell you the work and you just divide it and it'll be, real easy. So let's take a look at a couple of examples here. Okay, first example here, it says an engine number 1, does 1,500 joules of work in 20 seconds. A different engine number 2, does 1,000 joules of work in 12 seconds. Which engine is more powerful? Okay, so what we're going to want to do is, they told us the work here for both engines. So what we'll do is we'll do two problems. We'll calculate the power for each one of those two engines, and then we'll compare them and see which one is more. Okay, so the first engine, it says that the work was 1,500 joules and the time was 20 seconds. So I'm just going to use my power equation, P equals W over time, and I'll divide the work by the time and see what the power is. Okay, so 1,500 divided by 20, I punch that in my calculator, I get my answer, and I can see those two numbers both only had two significant figures. So I'm going to round my answer to two significant figures. And 1,500 divided by 20, I'll get 75. Okay, and that's 75, that's power. So I'm going to want to use the unit for power, and that's 75 watts. For the second engine did 1,000 joules of work in 12 seconds. So I'm going to take my equation, I'm going to divide the work divided by the time, so 1,000 divided by 12. Again, we're going to want two significant figures, so I'm going to round that off to 83. So punch 1,000 divided by 12 in your calculator, round it off to two significant figures, it's 83. And again, that's watts. So we can look at the two of them and we can say, okay, well, which one is more powerful? Which one was more, 75 or 83 watts? And of course, 83 is. So engine number 2 is more powerful. All right, one more example here. This one says, a man lifts a 25 kilogram box to a height of 3.0 meters. It takes 1.2 seconds for him to lift it to this height. How much power did he lift with? Okay, well, this one, they didn't tell us the work. So the first thing I'm going to do is I'm going to find the work. So I'm going to take a look at the equations for work, and I'm going to decide which one is going to help me find the work. Okay, and I can see that I know the box's mass. I know the height that it lifted to. And one thing I got to keep in mind that I always know is G. Okay, so I'm going to choose the equation. Work is mass times G times the change in height. So the mass is 25 kilograms, G is 9.81 meters per second squared, and the change in height is 3.0 meters. So I'll take those numbers, I'll put those into that equation. So I'll take 25 times 9.81 times 3.0, And then I'll need that to two significant figures. 25 and 3.0 both only had two significant figures. So I'll round that off to 740 joules. Okay, now that I know the work, now I can go ahead and find the power, because I know the work is 740 joules, and the problem told me the time was 1.2 seconds. So the power is work divided by time, so I'll take 740 divided by 1.2, and we need that to two significant figures, because both numbers had two significant figures. So I'll divide that, and I'll round the answer off to 620. And since that's power, the unit that goes on power is watts. So the power is 620 watts. Okay, so hopefully that helps us to be able to calculate power, right? Pretty simple stuff there. So until next time, take it easy.